Alright, hello, another problem from the ACS study guide. Problem is, which structure here, or which structure corresponds to the predominant form of this molecule near pH 7? So this molecule over here, right, is actually an amino acid, right? So we have a carboxylic acid group right here, and amine right here. So let's think about this. What we need to know is, well, first we got to consider this information. There is a table in the book that you should have down that will tell you pKa's, right? So this will tell you, let's see if I have this, if I can run through this quick, right? So approximately 5, pKa approximately 5, approximately 10, and approximately 15 for the pKa's here, right? So I know, right, water, H2O, is approximately 15. And so H2O is basically an alcohol, replace an R with an H. So alcohols are also approximately 15 pKa, right? So I know what goes next here is a positively charged amine. So I guess an ammonium, right? So if we have RNH3 plus, has a pKa of 10, right? And so at 5 is our carboxylic acids have a pKa of approximately 5, right? So drawing a carboxylic acid out here, right? That's approximately 5. And then less than 0 is just going to be if you protonate all these forms. Approximately 0, less than 0, right? H3O plus then is going to be less than 0. So ROH2, protonated alcohol, less than 0. Oops, right there, ROH2, positive charge. And, right, so then protonated carboxylic acid, which we draw like this, RCO. Okay, so we go, I believe you want to draw this, okay, H plus positive charge here, right, okay, so this table of pKa's you should basically have memorized. And so when we're talking about which structure is going to be in the predominant form in a solution depending on the pH, what we're going to want to do is take a look at this in terms of conjugate acid, conjugate base. So we can think about like an equilibrium equation, right? We'll take a look at carboxylic acid, right? Since that is relevant to our problem here, of course, right? So you could see this could be, if this were to act as an acid, its conjugate base would be RCO minus, right? So this equation, as written as an equilibrium equation, will tell us what pKa really means. pKa, the pKa of this this carboxylic acid is given by the point, the equilibrium point when this ratio of acid to the conjugate base is 1 to 1, right? So I'm going to write that down. Conjugate base 1 to 1. So what that tells us is, let's see, this pKa here is 5, right? So if this pH, if this is in a solution where the pH is 5, right, then you'll have as many carboxylic acids as you'll have the conjugate base of the carboxylic acids in that solution, right? And so what would happen if we increase the pH, right? If we make the solution more basic, then this guy will be more likely to act as an acid, right? And we'll shift the equilibrium now to that side if we raise the pH, right? So if pH, that's if pH is greater than pKa, we will be on this side of our equilibrium, right over here. And so same over here, this is the opposite case. If we lower the pH of the solution to less than our pKa, right? Now, what that means, if we raise the pH of our solution, we're adding more protons to our solution. So we're more likely to have some of the base that's in there pick up a bunch of those protons. Equilibrium would then shift to the left in that case, right? And we'd have more of these guys now in solution, right? So what does that tell us? We're at pH 7. This guy has pKa 5, right? And this guy, well, we can see this guy is right here. So we can say the conjugate acid of this guy has a pKa of 10, right? So if we're at pH 7, what are we going to have? Well, pH 7 for this guy, the pH is the pH is greater than the pKa, is what I meant to say, for the alcohol, so it would be in its O- form. For this guy, if we think of it in terms of NH3+, the pH is now less than the pKa, right? So we're over here, we are on the protonated side, the acid side, instead of the conjugate base side. So we'd be looking at NH3+ over here, right? So O-, NH3+, that's going to be answer C. All right, hopefully that helped. Thank you very much.